Hi everybody. First, let's refactor the project so that instead of using separate variables for x and y for position and speed and acceleration, we use vectors, which is the right way to think about it. It's going to make everything a lot easier. First, make sure that you have the framework. Here I'm displaying main and particle side by side, which I did by right-clicking and saying split right. Let's just run it as is to see what it does. So currently when I run it, we have a ball just falling with gravity. And if we see how that works, we have positions that get set to whatever the particle gets constructed with, and then speeds and accelerations start at 0. On this side, we see us constructing the particle with an x position of 300 and a y position with 10, which is close to the top of the screen, because the coordinate system for graphics, y equals 0 is at the top of the screen. So draw is running continually in a loop about 30 times a second. This paints the background frame, and then we're going to apply the force of gravity, have the particle update itself, and this is where it's going to update its own speed and position, and then it'll draw itself onto the screen. The reason that we're passing this object as an input to draw is because this object is a p-applet, which is the name for our graphics window. So if we want the particle to draw, it has to have access to a window to draw on. And so we're passing ourselves as an input to draw so that there will be a graphics window available. Okay, so let's take a look at how the particular methods work. So inside update, we take our two speeds and we add in the accelerations, because that's what an acceleration is. An acceleration is a change in velocity over time. Imagine that we have a ball here at time 0. At time 1, it's gone down by 10 pixels. At time 2, it's gone down by 10 more pixels. So as time increases, every second, it's going down by 10 pixels. You could say that its speed was 10 pixels per second. Is this accelerating downwards? Definitely not. Here's what it would look like. Boop, 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 boop. It would just be moving down at a constant rate. So if we are going to imagine what it would look like to accelerate, it's like every single second, it's traveling down by further and further. So something like this. So maybe in the first second, it's gone down by 10. So its speed would be 10 pixels per second. But then maybe from second 1 to second 2, it's gone down by 20 pixels. So its speed has increased. And then in the third second, its speed maybe has increased again. And so this is me illustrating what acceleration actually is. Acceleration is an increase in velocity. Not always an increase. It could be a decrease. But that's how acceleration makes sense. You are changing your velocity over time. So in the code, that's what we're doing right here. Update gets run once per frame, and we're saying whatever our acceleration is right now, let's use that to change our speed. Then once we have our speed, first block has begun. Then once we have our speed, we're going to use that to change our position. So if the speed is 10 pixels per frame, let's say, and this gets run every single frame, we would want our x position to increase by that 10 every single frame. And then here I'm resetting the accelerations back to 0 because the way I want to implement this system, I want to apply all of the forces every single frame rather than have the particle remember what forces are being applied to it. So we have the apply gravity method, and that is right here. And all it means to apply gravity is we're going to set our y acceleration to 0.2. If you're wondering what this f is, f means that we're going to interpret this constant as a float. Or rather, I should say this literal. We're going to interpret this literal as a float. If I leave it off, it's interpreted as a double, and now it's going to say that my variable expects a float, but I've provided it with a double. You could, of course, cast it this way, and that would also work. But if you have a literal right here, just having an f on the end for float is sort of a shorter way of ensuring it has the right data type. The final thing is draw. Remember, draw is being run from here. So main is passing itself as input to draw, and so it's going to get assigned to the variable window. And then we can use these draw commands. We can say fill, which will change the fill color to black, And then ellipse, we'll draw an ellipse centered at the xy position of the particle, And then each of these is a diameter. So the variable size is actually being treated as a diameter, and we should probably rename size to be diameter. Okay, so we understand how all the pieces work. Let's rewrite it all to use p-vectors. So instead of x and y, I can make a p-vector here just called position. You have to import p-vector. And the p-vector includes two components, an x component and a y component. So if I wanted to, I could do something like this. I could say position equals new p-vector 0, 0. And then I could say position.x equals x and position.y equals y. The only reason I'm doing it this way is to just show you that inside the p-vector, there are two attributes called x and y. So you can, instead of having our two xy variables separately, you can think about those two variables just getting bundled up inside of this single p-vector. It's a little bit silly to do it this way. A little bit more normal would be, let's just pass the xy coordinates into the p-vector constructor. And so now the x coordinate that we want is getting used when we construct the p-vector. And so now the x component of position is equal to that x value. Let's do the same thing for speed and acceleration. So I'll delete all of those. I'll just add vel for velocity and ac for acceleration. And we'll do the same thing. So we'll say velocity equals new p-vector 0, 0. Acceleration equals new p-vector 0, 0. And I'm creating acceleration and velocity to initially be 0. Okay, how does update work? Well, here I'm trying to add the acceleration to the velocity. So you might think we could do this. Now that we have acceleration and velocity, we could say velocity equals velocity plus acceleration. The problem is the plus operator here only works for primitive data types. So we can't, here it says operator plus cannot be assigned to p-vector. So p-vector has its own method that does addition. I'm pretty sure it's called add. So we don't say, all right, so let's do this. vel.add acceleration. And remember, this includes both the x and the y acceleration. You might say, hey, shouldn't we apply it to, shouldn't we save it into a result? And the answer is that you don't have to, because this version of add actually directly changes the velocity that you're adding into. So even though it's not an error to do this, it's unnecessary. You can just add acceleration directly into this. Now let's go ahead and add velocity into position. And then for resetting acceleration, you could say acceleration dot set, and then you can set the components to 0. That would work. You could say acceleration dot mult 0, and that scales it. That scales it to be a length of 0. Either one would work, and those are great ways of resetting the vector. For apply gravity, I think we want to generalize this a little bit. So instead of saying apply gravity, we're going to rename this as, hold on. Nope, okay, well I was trying to do a mass replace. That's okay. Let's call it apply force, and let's have it take a force as input. So actually, let's change it over here first. So we'll say p-vector force. So we're using a p-vector to represent a force because, remember, a p-vector has an x and a y. And so we can imagine the x and y components for our force. The force is just going to affect the acceleration. So we'll say acceleration.add force. And so that'll add the force into our acceleration. Let's say we have a force called gravity that's defined out here as a constant. I'm going to define it up here. And I'll say final, it's going to be called, its data type is p-vector. It's called gravity. And it's going to be have a 0 x component because it's not affecting the particle left or right. It's affecting it by pulling it down. And then 0.2 f is what we had as gravity before. So now we have this kind of constant vector pointing down that's gravity, and we're saying let's apply that particular force. The reason that this is going to be helpful for us is because later on we're going to apply forces other than gravity. You could have objects attract each other or repel each other. You could have something akin to wind or a magnetic force. There's all kinds of things that you could add. All right, final thing. So draw, there's no x and y anymore because now x and y are contained inside the position vector. So we'll say position.x and position.y. Okay, so we've done all of our cleaning up. Everything's a little bit shorter here. Let's just make sure that it still does the same thing that it's supposed to do. And it does. Fabulous. Okay, so come back in the next video and we'll actually start adding on to this so that it has more interesting behaviors.